So let's talk about reflections. You can pause the video and you're going to want to definitely copy this table down. So we're going to start with the original function here, and our function is h of x. So let's get a pen here that we can. Okay, so h of x is equal to 2 to the x. Now what I've done here is I've created two different functions. I've created m of x and I've created n of x, and those are all based off of this parent function, which is h of x. And then we'll talk about those. So basically what we've done here is we've created a table of values here just by plugging in the x value in each case. So for example, plugging in -2 right there in place of the x, that would be 2 to the -2 power, which is 1 over 2 to the +2, which is 1 over 4. So that's where we're getting each y value in each case. So we've done that. Now, we're going to kind of investigate what happens when we take the opposite of 2 to the x. So it's like kind of like multiplying a 2 to the x by a -1. That's very similar to what that negative is doing out there. Okay, so what happens here? Well, let's plug in this same x value that we plugged in before. We're going to plug in -2. So we're going to have -2 to the -2, and that gives you -1 over 2 to the +2, which is -1 over 4. So that becomes -1/4. And you can probably see what's going to happen in every single case. All you're doing is you're simplifying 2 to the x, and then you're just taking the opposite of that. So if you did, maybe just one more, and then we'll kind of see the pattern here, if not already seeing the pattern. We're going to plug in -1. So we're going to start with our -2 to the x. We'll plug in -1 in place of the x, and that gives you (1 over 2 to the +1, which is going to give you -1/2. So you can see that we're just getting the opposite of the original answer. The original answer here on the left-hand side was +1/4. We ended up with a -1/4. +1/2, we ended up with a -1/2. +1, we're going to end up with a -1. We had a 2 here, we're going to end up with a -2, and then a 4 is going to become a -4. So you should really make that connection that there is going to be a pattern to this, that all the y values became negative. So in general, what happens? If you start with f of x and then you take negative f of x, which is really what we've done here, then what that's going to do is it's going to change all of your y values negative. Y values become, we'll say the opposite, because what if your y value already is negative? So y values become the opposite. Okay, so what happens to this in coordinate notation? Well, if you start with your original x and y values, what happens? Well, that's going to change to x comma -y. As simple as that. Okay, now, what does this mean graphically? Well, let's just take one random point here. Let's just draw, and then we'll just start with let's just do 0, 1, because I think that's easier to do than some of these fractions. So I'm going to start with 0, 1. That was from your original f of x. So then what happens to it? Well, in this case, that became 0, -1. So we'll do the new one in red. Okay, let's continue in this fashion here. So let's do 1, 2. So I'm going to do 1, 2, and we're going to create a dot there. And then what happens in the new function when you apply a negative? Well, you go to 1, -2. 1, -2. So that it would give you something like that. So if you recall, the original function was y is equal to 2 to the x. The new function is y is equal to -2 to the x. Or you could just write it as this, -2 to the x. Either way is acceptable. we know what y equals 2 to the x looks like. It looks like an exponential function that looks like this. And then recall that there's like this asymptote right here on the x-axis. Now if you go to your new one, you can kind of see what's going to happen here is that you're going to get something that looks like that. And so if you recall from last year, we did reflections last year. So basically the blue exponential function was reflected across this asymptote or across this x-axis, and then it became this new one, this new red one down here. So anytime that you take negative f of x in general, negative f of x in general, that is going to be a reflection. Your graph is going to be reflected, so it's going to be reflection in the x-axis. Okay, some people say on the x-axis. That's totally fine. Some people say over the x-axis. I like to say in the x-axis. Okay, now one other thing. When we say that there was a reflection in the x-axis, that means that this is the line of reflection right here, right? So you need to know the equation of that horizontal line. Recall that the equation of this horizontal line is y is equal to 0. Okay, so this is called the axis of reflection. So you really should know the equation of that. That's kind of important. Okay, so we're done with the first set here. We've already done m of x like so, which was just a reflection over the x-axis. Now let's take a look at the other one. Let's erase some of these things here. And maybe I'll even erase some of this stuff too, so we can kind of look at the new one. Okay, so let's do this one in green. All right, so now we're going to do 2 to the negative x. So now what we're going to do is we're going to take a look at this one here. Now, if you notice here, all the y values have been done for you. So this time we're going to replace y over on the left side, and we're going to see what we can get for the x value. Okay, so we have a y value of 1/4 in this case, which matches our original y value over here of the parent function. And same thing all the way down. All of these y values on the right match all of these y values going down the left side here. Okay, so I'm going to plug in this y value right over here in place of this. So 1/4 is equal to 2 to the negative x. Now we have to solve for x. Well, I know that 1/4 is equivalent to 2 to the negative 2. And then the right side, if we let that be the same, like so. So now if you kind of look and match left and right sides here, the x value has to be a 2 in order for these to, because if I replace that with a 2, now both sides of the equation match. So I know that my x value is 2. Okay, now we try the next one. Now I go to 1/2. So I plug in 1/2 this time on the left side of the equation. 2 to the negative x on the right. I know that 1/2 is 2 to the negative 1 power. And this is just 2 to the negative x. And then doing the same thing, we can easily see that x is going to be 1. Okay, so we got a 1 here. Well, if you notice what has changed from the original parent function over to this function here on the right, this new function, is that the x values have just changed to their opposites. So this one was a negative 1, now it's a 1. This is a 0, the opposite of 0 is just still 0. This one was a 1, it's going to become a negative 1. This one is a 2, it's going to become a negative 2. So essentially, in order to achieve the same y value, these y values, we had to flip the x value to its opposite. Okay, how does this look symbolically? Well, symbolically, let's do it coordinate notation. We started with the original xy, that was these values over here. And what did those become? Those became negative x comma y, or the opposite of x comma y. That's coordinate notation. Function notation. What did we do? We started with f of x, right? This was our f of x. I'm calling it f of x, even though in this case it was h of x. What do we do with that? Well, we replaced x. If you notice here, this x value was replaced with negative x. How do we show that here? You just write it as f of negative x, like so. Okay? So I kind of like to look at this as an inside-outside thing. Since this negative is an inside thing, that's going to change the x values to their opposites. In the previous case, we had negative f of x. See how this negative is outside. If it's outside, it's going to change the y value to its opposite. Okay, now what does this do? Let's look at this graphically once again. So let's take our ordered pairs here. I'm going to take 2 comma 1/4. Let's see, 2 comma 1/4, which is going to be over to here somewhere. And then the next one I have is 1 comma 1/2. And then 0 comma 1. And then negative 1 comma 2. And so basically you can see that by graphing these ordered pairs that it's going to go this direction. Like so. So what happened? Well, we took our original blue graph and we've reflected it this time along the y-axis. That was your line of reflection. So anytime that you replace x with negative x, this results in a y-axis reflection. Or we could say that it was reflected in the y-axis. Now, since this is your line of reflection right here, what's the equation of that line? Well, it's a vertical line. And vertical lines have the equation x is equal to a number. In this case, our number is 0. X is equal to 0. So this is the axis of reflection. That's the equation of the axis of reflection. Okay, so let's just kind of recap these. Let's put all of these together. So we started with h of x. And then first of all, we got m of x. So let's erase some of these things here. Okay, so we went from, to get m of x, we took h of x and then we attached a negative to it outside. And so that resulted, recall that that was this stuff right here, that resulted in the original x value staying the same, x comma y stayed the same, became x comma, all of these y values became the opposite, x comma negative y. And that was a reflection in the x-axis. Okay, so that was our first one. Our second one, how did we get n of x? What was done to make n of x? Well, we look at n of x and we took h of x and we replaced the x value with a negative. So we took h of negative x to obtain n of x. Okay, so what did that result in? Our original x comma y values from the n from the n of x became negative x comma y. And that was a reflection in, we reflected in the y-axis. Okay, so this happens in general. Once again, just recap. You put a negative outside your function, it's going to reflect in the x-axis. You put a negative inside the function where the argument was, that's going to reflect it in the y-axis. All right, let's do some example problems. All right, so you can copy down this first example here. So we're going to rewrite each function g of x in terms of the basic function f of x. So basically, your parent function was here. We started with that, and then we converted it to this. So we just have to ask ourselves, what did we do? Well, you can easily see that all we did was we attached a negative to the f of x. So we just applied a negative, or you could just say you multiply by a -1. And that was outside the original function. So it's like it's like taking this, applying a negative to it, like so, which results in this. So symbolically then, in terms of the basic function, what we've done is to attain g of x, we've taken the opposite of f of x, and there is your answer. Simple as that. All right, let's try another one here. So we're going to take f of x is equal to some long function like so, and g of x is equal to 3x squared minus 2x plus 5. Okay, now this one looks a little bit tricky because we're like, okay, well, what did we do here? Well, let's test it. Did we attach a negative to the f of x? If we did, it would look like something like this. You would take your original f of x, and then we just put a negative outside. If you do that, then you would distribute the negative, minus 2x, and then minus 5. Is that is that what we did here? No, not at all. So it was obviously not this scenario right here where it was a reflection in the x-axis. Maybe it's a reflection in the y-axis. Well, let's see. In order for that to happen, that means that we would replace f of x, we'd replace every x value with negative x. So we would say f of negative x. What does that look like? Well, let's replace this value and this value with a negative. That would give you 3 times negative x squared plus 2 times negative x plus 5. So let's see how that works out. F of negative x is equal to 3 times, now if you square a negative, it becomes positive. So that becomes positive x squared. Positive 2 times negative x is negative 2x, and then positive 5. Oh, hey, look at that. That's exactly what happened in the transformation there. So, how do we write this? To obtain g of x, we took f of negative x. We replaced every x value with a negative x. There it is. All right, now, so let's look at the next type of direction here. We're going to represent each reflection using coordinate notation, and then we're going to identify whether it was a horizontal line of reflection or a vertical line of reflection. Recall, horizontal line of reflection is the x-axis, which is y equals 0, and then vertical line of reflection is the y-axis, which is x is equal to 0. Okay, so let's take a look at this first one. Well, you got to ask yourself once again, was the negative applied inside or outside the function? Yeah, you can see it was applied outside the function here. So in order to obtain g of x, they took the opposite of f of x. And now we're going to use coordinate notation. First of all, you should recognize that that is an x-axis reflection. So if you go back up to here, remember if it's outside, that's this one right here. That's x-axis reflection. So we have x-axis reflection. and it's about the line y is equal to 0, like so. And then recall, look at the notation here. X comma y becomes x comma negative y. So x comma y becomes x comma negative y, like so, and you're done. Now take a look at this one. What happened here? Well, did we apply the negative to the inside or to the outside? It might be a little bit difficult to see. So if we take this original f of x, if we applied it to the inside, then the x, just the argument x, would just be replaced like so. But that's not what was done here to find g of x. So let's take a look at this. What they did was they attached it to the outside, or applied it to the outside. Now if you distribute that in, you get negative 3 to the x minus 2, which is exactly what we did here. Okay, so how do we do this once again? Well, to get g of x, we took the opposite, once again, of f of x. And so it's going to become the same exact thing as what we did before. It's going to be an x-axis reflection. And then your original x comma y is going to become x comma negative y, like so. Simple as that. Okay, so we're going to continue with these here. Write a function g of x to describe each reflection of f of x. So you're given f of x here, and then I'm going to tell you exactly how I want you to reflect it. So you're going to reflect this one about the x-axis. So looking back up here, an x-axis reflection, reflecting in the x-axis means that you take the opposite of your function. Okay, so we go here, and so to form g of x, we take the opposite of this function right here. Take the opposite of that. So that gives you g of x. If we just kind of simplify this a little bit, distribute your negative in. Negative negative is positive, and then negative to the 4 becomes minus 4, like so. And we're done with that. That's your first one. This one is a reflection about the y-axis. And recall the reflection about the y-axis is the second one. So reflecting the y-axis, you change it to replace x with negative x. So that's what we're going to do here. So to find g of x, we take x from our original function here, replace it with negative x. That gives you g of x is equal to negative 8x minus 5. And then there is your new function there.